Welcome to an example, which we got a boat sailing towards a cliff that rises 237 meters above water level. Let theta be the angle of elevation from the boat to the top of the cliff, and let x be the distance from the boat to the cliff. Well, a picture will help a lot. So let's do it. So first off, we have ground or water. Actually, so I'll make it blue. Oops, I thought I was on the line drawing tool. So here we go. So perfectly calm sea. So that's the water. Okay. And then there's this cliff over here. I'm just going to draw it this. So this is the cliff. And the cliff is 237 meters above the water. And the boat's over here. And it's talking about that'd be the angle of elevation from the boat to the top of the cliff. So that means it's that line right there. There's theta. Is that making sense? An angle of elevation means from flat up. From flat up. So there's theta. It's from the boat to the top of the cliff. Okay. So there's our setup. And we know this is a right angle. We're assuming. Oh, well, it's got to be because they gave us the height of that cliff. And height means straight down. You know what I mean? You might say, well, how do you know that the cliff isn't kind of like that or something like that? Well, even if it is, right here, we would take the height and go straight down, even if it's to water or whatever. Well, actually, no, we're assuming the cliff is straight up and down. Yeah. Let me pack that up. We're assuming the cliff is straight up and down. So we get a right angle here. Now, first thing we need to do is they want to find an equation for theta in terms of x. Well, you see, when we have a right angle, we can use SOHCAHTOA. Remember that from trigonometry? Whenever you have a right angle, you can use SOHCAHTOA. H stands for hypotenuse. Remember what the sides are? So this is the side opposite. This is the hypotenuse, which makes this side the adjacent, right? So from the angle's perspective, this side here is opposite. Hypotenuse is always across from the right angle. Remember all that from trig? Okay, so now here we go. So that means now we need one of these trig relations. How do we know which one? Well, look at what you have theta. And oh, well, I forgot one thing. Let x be the distance from the boat to the cliff. I forgot to put that in. X is this distance from the boat to the cliff, right? X is that distance from the boat to the cliff. Okay, so there's X. Okay, so and I want a connection between theta and X, right? And theta in terms of X. Well, what's going to relate theta and X? Well, X is the adjacent side, and I know the opposite side. So I want to use a trig relationship involving opposite and adjacent. That's tangent. See how I'm figuring that out? I'm not going to use hypotenuse at all. Why not? I don't know it. There's no number here. And it's not x or anything. I want to use these two sides because those are my x and my opposite where I have a number. So I want to use adjacent and opposite, adjacent and opposite. That's tangent. That's what tangent stands for, opposite adjacent. Okay, so here we go. We're going to use tangent of theta equals um, opposite over adjacent. So what is the opposite? 237. What is the adjacent? X. That's opposite over adjacent. Tracking with me? Opposite, adjacent down here. And there it is. Okay, now, but we got to get theta alone. See how they got theta alone? So how do we take that? Let me rewrite it right here. And get that theta alone. What are we going to do? Can you just divide by can you just come in here? Sorry, my pen's You just come in here and divide by tangent on both sides like that? No. Really important that you know that. This does not mean multiplication. I say, yeah, it is. There's no symbol. It means times. No. Remember, when something comes after a function, sine, cosine, tangent, f, g, h, any function, that's plug-in. That theta is plugged in like bread plugged into a toaster. That's always my function analogy that I've made up. So is that making sense? This does not mean tangent times theta. It means tangent of theta, like f of x. It's plugged in. It's buried in the toaster. It's not multiplication. You can't, therefore, you cannot divide by the tangent. It's plugged in. Well, okay, well, then what are we going to do? How do we get rid? We got to get rid of that tangent, right? You do tangent inverse. Whatever you do to one side, you have no choice but do the same to the other. And these cancel. They're opposites. And so we get theta alone. Theta is inverse tangent 237 over x, which is what we have there. So there's the first answer. Now, second part, they're going to say, okay, find the rate of change of theta with respect to x when x is 187. That rate of change, what is that? What does that language mean? Rate of change of theta with respect to x. That means theta prime. Derivative. That's rate of change. So if I go, oh, okay. So now bring this down. Theta equals tan inverse, tan inverse 237 over x. Okay, now it's derivative time. So theta prime, what is it? Well, how do you take the derivative of tan inverse of anything? The derivative is, you know the rule? It's 1 over 1 plus x squared. Whatever you have plugged in here ends up right there, squared, right? So I'm going to say, okay. So this is going to be 1 over 1 plus. Now, first off, you can do that, and you're going to do it squared. Oh, hold on. Hold everything. Let's make life easier here. Do you see how this is a fraction? And in a minute, I'm going to have to do the chain rule, take the derivative of a fraction, which requires quotient rule. That's a pain. I don't want to deal with it. Instead, let's just rewrite this thing as 237x to the minus 1. Right? Because that's the same thing. And now it's not a fraction. See, x to the minus 1 power is the same thing as moving the x back down. Right? Remember, negative powers are unhappy where they want them to move to the other side. Then they become positive 1 or just regular x. That's the same thing. And then this is not a fraction. It's going to make life a lot easier. Rewrite not a fraction. That'll make life a lot easier. So now back to it. So where were we at? We're doing the derivative of it. So you go 1 over 1 plus, and then this squared. I'm going to go 237x to the minus 1 squared. Okay, but we're not done there. Why not? Because remember, if the inside of any function is not a simple x, you must do the chain rule, another link in the chain. Meaning you got to multiply by the derivative of that guy. So I got to take the derivative of that guy, the derivative of 237x to the minus 1. That's not too bad. Sorry, it's just getting kind of scribbly, isn't it? Let me, I don't know where else to put it. Oh, come on. So derivative of 237 to the minus 1. Gotta do that right here. So what's that going to be? The minus 1 goes right there. So minus 237 x to the minus 2. Subtract 1 from the power, right? That's the chain rule. When the inside of any function is not just a simple x, then you got another step where you multiply by the derivative of the inside. That's the next link in the chain rule. All right, so let's clean that up just a bit. So we got theta prime equals 1 over 1 plus 237 x to the minus 1 squared. And then this is really right here. This guy is really over 1, so he'll just go up there to the top and multiply by that 1. So that'll just be minus 237 x to the minus 2, like that. So there's the derivative. But now they want us to plug in, let me get down colors here, plug in x is 187. So now you come in and go, okay, so 187 for x, 187 for x. Plug it in, hit the buttons on your Desmos calculator, and you'll get the answer they got, like that. It's negative because, oh, and the units, by the way, um, are radians per meter. Radians per meter. So the change in theta as x grows. So as the boat, what that means is as the boat heads out, the angle gets smaller and smaller. That's why it's a negative answer. We'll talk more about that in related rate section. So there we go. There's the answer. And the units are radians per meter. How do you know it's not degrees? It's automatically radians when you do the derivative rules. The derivative rules for sine, cosine, tangent, the inverse function, trig functions, inverse tangent, inverse sine, inverse cosine, automatically they only are true in radians, not degrees. So it's radians per meter, something you need to know. If you're doing derivatives of sine, cosine, tangent, or inverse sine, cosine, tangent, you got to be in radians. The rules are not true for degrees. Got to be in radians. So it's radians per meter. Why is it that? Because it's the change in theta with respect to x, right? Theta x radians per meter. And so there we go.